Okay, good morning, my dear students. This is for class 12. Right now, we are studying optics, a very big unit carrying 14 marks altogether. Today, I will be explaining this Huygens principle. Okay, and usually what this will carry 3 marks, especially the principle. You need to write down all the principles. Okay. As per Huygens principle, it says that any point you take it, okay? Any point you take it, we say if it is the source of light, then this source of light, this will be emitting light waves in all directions, like this, emitting here, like this. Not only in this direction, in all directions, okay? Then if you choose different points on any of the line or any of the, say you call it a wavefront here, then these particles like 1, 2, 3, 4, all these particles must be lying on that line. Then this line will be called as wavefront here. So Huygens says that, the first one says that, number 1, each point or each particle, you can call it, is point or it may be particle, like this, 1, 2, 3, okay? Equidistant from the source, and all of them should be vibrating in the same phase, okay, from the source and vibrating in the same phase. All of them lie in a plane, like this type of plane or a line, which is, this is called as, what do you call it? Wavefront here. Okay? This is the first principle. I repeat again. If you choose some points or some particles on the line, and all the particles should be equally distant from the source, and all the particles should be vibrating in the same phase, then this line or the plane on which all of them are lying is known as wavefront. All right? And the second one, you see, say this is the source, for example, and here is the wavefront. Then each particle, like 1, 2, 3, they will behave as the parent again. It means 1 also will start emitting light wave, 2 also will start emitting light wave, 3 also will start emitting light wave, 4 also will start emitting light wave here. Okay? And these waves are known as, we call it as the secondary wavelets. Alright? And if you join them using a tangent here, suppose if you draw a tangent touching all these circles, this is known as forward envelope, and this forward envelope will represent the new wavefront here. This will be the new wavefront. So for the present moment, this is the wavefront. But once you draw the tangent here, the tangent will represent what? The new wavefront again. Okay? Then you can choose some other points here again, like another point is chosen, another point is chosen, another point is chosen here, another is chosen here. There you need to draw another secondary wave, let's say like this. Alright? And one more tangent. So that tangent will represent the new wavefront again. Like this will keep on shifting here. And the light propagates in all directions. There is a way how it propagates. Okay, so how do we say? It says that its point or the particle will emit light waves which are known as secondary wavelets. Okay, this will be known as secondary wavelets. All right, and number 3, you can include one more here. The forward envelope enclosing the secondary wavelets will represent the new wavefront after a time here. Let us say the time be t here, for example. It means if it takes some time to travel from here to here, let us say the time is t, for example, then after a time of t, this will be your new wavefront here. All right. So this is the principle of Huygens principle. I will send you with another note, separate note, or you can just copy it down from here also, it's still okay. So in a simple language of explanation, I repeat again, if there is a source of light, you need to draw a line, and on that line you should find different particles, 1, 2, 3, 4. These particles will be equally distant from the source. At the same time, all these particles must be vibrating in the same phase. Then this line will be called as a wavefront. Okay? Then each particle will be emitting light waves, just like the parent is doing. So these light waves are known as secondary wavelets. And if you draw a tangent touching all these circles, this will represent the new wavefront after a time of t. So right now, just think that a time of t has passed. So you have to take different points on it again, like this, 1, 2, 3, 4, 5. So right now, this is the wavefront. Then after a time of t, another time t, this will be starting to send out wavelets, and after a time of t, this will be your new wavefront again. Okay, like this. This will keep on shifting, just like shifting here, 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 like this. Then all this shifting of the wavefront, this will indicate propagation of light. Okay, at least you can include one more. Suppose this is a source of light, and if you draw a line, this will be called as ray, and this ray represents what? Direction of propagation of light. Here you can include that in the principle. The ray that represents the direction of propagation of light is perpendicular to the wavefront. Okay.